both sharing, but you, all right. Thank you very much. Um, One thing I'm going to point out is I actually was not one of the authors of this assessment tool. That's why Kathy's here, because she can speak to that, and I'm going to speak to the assessment tool as a practitioner and part of Kathy's research team. So um, we're going to be talking about the iSTAR, which is Inquiry in Scientific Thinking, Analytics, and Reasoning. And Kathy and I are um, doing the talk. And one thing I do want to point out, we encourage questions, interrupt whenever. And so we are kind of going to share the information first, and then we'll also have more time for questions. So the primary developers, um, is this where you were going to start, Kathy, or was I? I okay, I'm doing it. Okay. Sorry about that. I had that written down, but then I forgot. All right, so Lei Bao and Kathy Koenig created this iSTAR assessment tool, and so that's the information of where both of them are. So we are really glad that you're here, and to give us a sense of what you want to get out of this, or why you're interested, why are you here, and what kind of settings do you teach in. This session is open to both to your college, for your college, or whoever wanted to sign up. And so if you're familiar with the waterfall activity, basically there's a question prompt as you see on the screen, and then all the participants will type something into the chat, and you wait until I give you the sign, and then you hit submit at the same time. And then we'll get a sense of, why you're interested in iStar and what your setting is, what kind of class, lecture or lab, whether it's calc or algebra based, etc. So take a minute or two to type something. Why are you interested in the iStar? And what kind of setting do you think it might work for you in? And when you have typed it, give me a thumbs up emoji so that I don't keep you waiting too long. All right, got the first thumbs up. Good. All right, hold off with submitting until I give you the call another 15 seconds. Hopefully we'll do it. All right, go ahead and submit, please. Okay, so we've got, all right, time to put the glasses on. Just interested. We have a high school teacher. Um, we have to your college faculty, interested in student learning and critical thinking, algebra-based lecture and lab, and interested in something like the Lawson test, but a little bit more modern. So great. That's all great input. So this is what our session will look like. We have the motivation for developing the iStar, what the development process has been, and then iSTAR has been tested and validated, the skills that iSTAR assesses, so what you can use it for, and some example questions, results at Research One University, and then how it's been used at a two-year college setting. And then finally, we're going to have you guys talk about how you might use it in your setting, in your classroom.
All right, so
So,
I'll talk a little bit about the motivation for developing iStar. And so we're about at 20 years that we've been thinking about this topic. Not developing the test the whole time, but definitely thinking about it. And for me, when I was teaching high school and then went back to grad school to work on a PhD in physics education, I was really interested in decision making, especially evidence-based decision making that we use in a science classroom. And at the time, the Lawson Classroom test of scientific reasoning was around, and I could use it for certain populations. But we were really looking for a tool that would evaluate college level students. Um, there's a ceiling effect with the Lawson test, particularly with the engineering population that we have at UC. And so out of the 18 or so questions on the Lawson test, we really weren't getting valuable information. And on top of it, the Lawson test is limited in the scope of skills that it assesses. And we were really interested in some of the more higher level reasoning skills associated with like causal reasoning. So that was really what we were looking for. And also we wanted to write a lab curriculum that would promote these skills with students, and we needed a tool to evaluate it for its success. And so, as I mentioned, we started this quite a long time ago. And so the first step was to define what are those skills, because up until that point, we had the Lawson test and Lawson's work to build from. The Lawson test was actually designed for high school students. So the subset of questions were somewhat narrow, and they didn't have a lot of breadth to them. And so after gathering data for quite a few years and trying to explore what we were really looking for, we started with control of variables because that's really the foundation of all scientific investigations. And so we have a paper that came out in 2016, and it describes a large body of work where control of variables has a lot of levels, if you will. So just recognizing that something needs to have a control variable would be a very low level kind of skill. But being able to recognize when there's multiple variables that maybe having confounding variables or hidden variables can be much more challenging. And so we developed sort of a range of questions to go with these different skill levels that we identified as necessary and something we wanted to promote in our curriculum. And so that's what the 2016 paper is about. And many of those questions that you'll read about in that paper we're still using today on the iSTAR. And so we had a paper come out a few years ago that has the current version of iSTAR. And we've extended from control variables into data analytics because once you've collected data in an investigation, you obviously need to do the analysis. There's a whole set of robust skills involved in that step. And then ultimately, we're trying to get our students to a causal decision-making stage. You know, there's common characteristics for students as they think correlation is causal. And so getting them really to recognize how do you determine if something's a causal relationship, what does it look like, etc. And so the assessment tool goes into depth into those two areas, which is what the work we've done for the latter part of our research period. And that paper came out in 22. I think you have to go back one slide, maybe.
ah,
So I've already mentioned that there's three different kind of areas that we're focusing on: control variables, data analytics, and causal decision making. And so one of the steps that we really had to spend time on was just the language of the questions. If you've ever written a test and you know students ask you questions during the test, it's confusing, or that you use a word they don't recognize, or they interpret it differently than you intended. So a lot of effort was put into just the language of the actual questions. And part of that was through student interviews early on, etc. And then when we would use them with students and test them with students, we would have to look for the difficulty level. So we would look for discrimination things such as, is this question too easy where 90% get it correct on the pretest? Okay, that's not a good question. Or if only 20% get it correct on a post-test. So that would be things that we looked for. So we'd collect the data, look at what, how the questions scored, and then make revisions to kind of get them in a mid-range where we could actually see growth, but not have them have a ceiling effect. And then, as Krista mentioned, we did validate the tool and measures of reliability. And because this is a sort of a short presentation, I'll just leave that that's in that 2022 paper. And so the iSTAR that we're currently using in our courses for, which I'll explain later how we're using it, is 22 items. And if you do the math on this page, it's like 35, 36 questions is what shows up on this screen. 36 questions is too many to ask these students. So we're going to give you some examples here in a little bit. And when you see those, to answer 36 of these in a row it'd be difficult. You'd be tired. So there's a lot of reading in some of them. So we narrowed it to 22 questions, but we have this pool of questions. And so I share the slide with you because if you're really interested in just one of these domains, know that we have quite a few questions within that domain, but we've narrowed it to 22 by looking at over time, we would give like one section a subset of these and another section a subset. And we started to learn over time which questions students sort of answered the same way so we can narrow it down.
So I'm going to be talking about an example of each of the different areas that iSTAR assesses. And the first area, as Kathy said, is control of variables, because that's a necessary skill to be able to do any of the other, um, higher level scientific reasoning skills. So here we have Tom and Jerry are good friends and go fishing together most weekends. They use the same type of fishing tool, etc. And so as you read through that, you'll see that the information is also on in the table there. And this is a real life context. We have three different variables, but there's no data provided. And so the question is asking, and that's below the table, ignoring all the influences from the environment and using the conditions shown in the table above, which the following variables can be tested for the possible impact of the number of fish caught. And so in we have all these different choices, which the number of choices also makes it more challenging for students and so they have to look at this and figure that out. We have all of those 22 questions. We have another document that we will share with you if you're interested, but we're not going to record it and post it online, that describes what the answers are and then what type of skill those questions are getting at. So anyhow, that's our first one. Then the data analytics question talks about a group. You observe, you're traveling in another country, you observe a group of people playing a game of dice with a six-sided dice, and it gives some data. You counted the when the die was tossed 1,000 times, the blue side shows up 720, the red shows up 280 times. So if you were to toss that another 100 times, how many times would the blue side turn up? So this is a real life context, thus there's likely to be bias, and it uses probability. And so this is a data analytics type of problem for the students to solve. And then a causal decision-making example that's part of the 22 questions is a visitor traveled to Africa to tour a natural breeding environment of giraffes and noticed that a type of tall tree that grew fruit only at the top of the tree, and noticed that the giraffes who frequently ate this fruit appeared to be stronger and taller, than those who could not reach it. So based on the observation, which of the following statements can be concluded? And so what this gets at is it a correlation or is it causal? And there's hidden relationships that they have to consider. So can be a very challenging um, concept for students. And this is one of the assessments to see how they can do with that.
And
So
so,
that
go ahead. So I'm going to share with you some of the results from main campus, the UC main campus. So this is like the Research One institution. And we are assessing students in our introductory physics course lab. And so the data you're looking at are students either in our engineering physics 1 course or our algebra-based, mostly health science course. And so the total score is kind of in the middle of the graph there. So you can see the total score pre to post. And then we also look at, so that's just sort of like an overall measure. And then we look at the skill domains. And so control of variables is the skill that we've seen large shifts in from the beginning. And if you notice, the title of this slide says 2019. So besides writing an assessment tool and working on its validation, we were also developing a lab curriculum, which was also NSF funded. And the lab curriculum is very simple. It follows the AAPT guidelines, which I'm sure you're familiar with the lab guidelines. So it's very inquiry based, but it's really driven by teaching skills. And the skills you see on the screen are what we're driving towards. And the ultimate goal is that students can leave the course with evidence-based decision-making skills, that they understand the importance of evidence. And so if you notice the questions that Krista read through, some of them were in everyday context, like the fishing question, which the location, the fish hook, etc. matter. And when we were doing student interviews, I still remember with that question, some of the students literally said to me, "Well, I don't need to read the question. Everyone knows location matters." And so this is where this personal bias gets in the way of evidence-based decision making in these everyday life decisions. And so we're really trying to use the lab context in this curriculum to focus on the data. And so the skills on the screen are what they really need to think about. So in 2019, you can see we had these great shifts in control variables, but we didn't get good shifts. There were no shifts in data analytics and no significant shifts in causal decision making. So we went back to the drawing board with our lab curriculum and we started integrating activities, pre-lab activities that were really targeting those skills. And some of the pre-lab activities were things like the students were given a scenario and were asked to think through and kind of guide them through these different contexts. And then they would practice it obviously in the lab course. They would collect lab data and then they would, of course, practice these skills. And so you can see the effect sizes on the right of the screen. We're starting to see some effects in data analytics and causal decision making. So we're starting to see some movement, which tells us as researchers you can promote these skills in a physics lab course. And then in 2025, last spring, our most recent data, you can see we were even able to push data analytics and causal decision making a little further. So there's small effect sizes, but remember, we're focusing on skills, not content knowledge. And skills are much harder to move on a pre-post test than a content knowledge. So this is really exciting to us that we can see this movement, and it also gives us a sense of what kind of curriculum or features of a curriculum in a lab course are going to promote these skills. Oh, sorry, this is
so
mine as well. I forgot about this slide. So I've kind of already mentioned a little bit of what's on the slide. But if you look at the research literature on the development of SR, many people have heard of the lost in classroom test of scientific reasoning, which was developed for mostly the high school population. But most of the work that our work is grounded in terms of developing SR with students, comes from the work of Deanna Kuhn or Claire, and they primarily work with middle school students. And so we were really using this research platform for the last couple decades to try to add to the research literature on how do you develop or address these skills in college students, and what kind of tool can we develop to measure this shift. And then, of course, we used it to develop and revise our lab curriculum, as I've already discussed.
And just to clarify, SR means scientific reasoning. We often shorten that in case you didn't catch that along the way. So my role is as a practitioner at a two-year college. And so what I want to know is, do students' scientific reasoning skills change in the algebra-based physics where we use that SR lab curriculum? And then because I have small samples, I'm also curious for our setting at our college, are there gender differences? Um, I had some demographic information available for a couple data sets that I dug into gender as well, just to see, is there any difference? So in 2021, you can see, and my colors are a little bit different. So the dotted blue is total scientific reasoning skills, and the data analytics is in green. Our control of variables, COV, is in red, but the causal decision making, there was no change. And you'll notice my error bars are much, much larger, and that's because of the small sample size. Between the various lab sections, we only had 43 students. So in 2023, we did probably our first iteration of using some of this new curriculum that had causal decision making, um, that specifically addressed causal decision making with some extra questions and parts of it that we hadn't used previously. So the good news is the causal decision making did increase. Um, our effect sizes are small, but they exist. The trend exists. So I was curious, did it matter? Since I'm teaching algebra-based physics, I tended to have more, and that's not just me, but my colleagues who use the lab curriculum as well. We have generally have more females than male students, and so it was interesting to me. That some of those skills, the females came in lower with COV skills, but they had a similar, they did increase. Um, and all of our data analytics that fall were really low and they didn't make any progress whatsoever. But the skills I was really focusing on were COV and then the causal decision making. So for me, that gave me some information. Since then, I've also looked at sense of belonging. How does that affect? Well, I haven't done the research yet, which is why you're not going to get a slide yet. But is there a correlation between sense of belonging and how they, develop these scientific reasoning skills? The literature using Lawson's test of scientific reasoning, there's an article that we've looked at that compares FCI scores with scientific reasoning. So the iSTAR is more appropriate to our students because of the ceiling effect of the classroom of the Lawson test. So if you're interested in using the SR or the iSTAR in your classroom, where do you start? And the most important thing I find is, once you figure out where to start, and so today was a good place as where to start. And at the end of this, we're going to tell you how to get the iStar, which is going to be email Kathy. But then once you have the iStar, what do you do with the results? The pretest results are really important to understand where your students are starting because then you can think about the skills that you're interested in developing in your lab setting or your class setting, depending on what kind of class you're going to use it in. And by using those pretest results to influence your own practice, you have the ability to improve their skills just because you're aware of where they are and you know where you want them to be. So if you're going to do any of these assessment tools, any of the research assessment tools that have been discussed throughout the year, I strongly encourage you to be very diligent in thinking about how are you going to use the pretest results so that you can get those better post-test results. So, so this is the part where we'd like you to chime in. How could you use the iSTAR to improve student learning, and what questions do you have? So that actually concludes the end of what we were going to talk about, but I want to hear from you. So go ahead and chime in, unmute yourself.
All right. Well, thank you. So anybody who wants to jump in, please go ahead and do it at this point. And so maybe I can ask a first question, having to do with the actual content of the lab. Do you have like specific activities that are designed in with the iStar in mind, or would that apply to any standard lab curriculum? How did that go for you?
Do you want to take that, Kathy? I can. It doesn't matter. Um,
I dropped my mouse and now it's not working. Oh, the battery popped out. That's all. Um, yeah, so early on when we were developing this tool, we were using Lawson in a regular traditional physics lab, and then we were using it in an inquiry-based lab, and we saw big differences between the Lawson and the other one, although we couldn't use a lot of the questions because of ceiling effect. So, I forgot what your question was.
Well, my question basically this way. So the iStar is a diagnostic. I mean, the way I understand it is diagnosing the improvement of students in various categories. Can I stick that on top of an existing traditional lab curriculum, or do I need to prepare a modified lab curriculum to go along with the iStar? What would be the better option? Or
So, what I would do if before you jump too far is just to give it to your students pre-post
Hmm?
with your current curriculum. And as Krista said, you're going to find out what skills do they already have and did they make any adjustment on the other skills. All of our curriculum now has been totally flipped over into a reasoning-based curriculum, and we can provide you access to that if you have interest. So the students answer. It depends how many labs, how many weeks you have during your lab course. We can usually get 4 or 5 full investigations done in a 12-week, 14-week course. So, like what affects the period of a pendulum would be an example of a research question the students would be given. And then over 2 to 3 weeks, they would address that research question in the lab, making predictions, a lot like modeling instruction, graphing their data, coming up with mathematical models. But woven into all of that is taking it a step further. And they'll be asked specifically, especially at the end of the term, okay, you have this relation from the data. Is this a causal relationship? Can we say force causes an acceleration? Well, it does if mass is constant. So they learn the language of, so we were very intentional, put it that way. Um, So it would be really interesting to give it pre-post in your current curriculum and then see what happens and then start to make adjustments and see if you're moving that needle in a way you want it to go.
Okay, that was good. That's actually pretty good because we've been doing a sort of a series of surveys specifically designed for the with the sense of belonging in mind. So we've been asking that same question for about 3 semesters in a row now. So we have a pretty good base to start from, and I think yeah, adding the iStar would be interesting at this point.
any other questions?
Yeah.
The question that I would expect everyone to have is, how do I get this? And this applies whether you're interested in the iStar or if you would like to know more about the scientific reasoning labs that we use at our two-year college, and also what Kathy's developed for the broader, we've had people at high schools, at two-year colleges, at four-year colleges adopt the lab curriculum. But
So that was
what I'm
designed after the iStar was put together. So the lab curriculum was in response to the iStar, okay, together.
I,
actually,
I, And say iSTAR and the lab curriculum were kind of developed in parallel. They kind of fed off each other over the last decade, informing each other, so to speak. So we have iStar and Qualtrics. So if you wanted to give it to your students, I could simply give, if we make it as easy as give your students a link. I'll
Mhm.
give you a link to give to your students. They could take it on Qualtrics. I can send you the data with, I have a grad student that would do the analysis and send it to you. You could also, I believe you can share a Qualtrics and like you can dump it into your own Qualtrics account. I'd have to Google how to do that, but I've had it done before. We could give you just a hard, like a digital copy, and you could print it and give it to your students. So we're pretty flexible. And as Kristen mentioned, we have a document that we didn't want to put on the video, but it will have each question and it will tell you not just the answer, but what are the skills that are being assessed. So when you get the analysis back, you have a better sense of what it means.
And that's another, you could ask for that document and Kathy or I will send that to you as well. We just didn't want it to be out there to invalidate the tool.
Makes
And when
sense.
I say analysis, we've created an Excel template. So we would just dump your data in this template and we could even give you the template. And so you can look like down the whole column, like, oh, on this fishing question, this is how my students did. What was the most common answer? How did they do pre and post? So you get a lot of like, you can really dig into it and see things that I'm not just, when I say I'm giving you analysis, I'm not just giving you a graph.
Okay.
And I noticed Chris put into the chat, Kathy and I actually did a workshop last year in the spring of 2024 that you could log in and see that if you want more than what you can see in, I think it was a 3 hour session, then you might want to, if you're going to the AAPT summer meeting, Kathy will be doing a workshop there on the scientific reasoning labs that's 4 hours. So I encourage you if you have interest. It's a great workshop. I'm biased. I've been working with Kathy on that workshop. I just can't do it this time. So, but the Zoom link that Chris put in the chat would be a really good, or you can access it on the optics webpage under professional development, SR Labs.
So we have a question online from John, and he's asking, can you talk about how using this in a fully online course would be or not be able to do, would not be doable, or any problems you foresee in an online environment?
So you mean using iStar or using the lab curriculum or both?
I'm guessing iStar, but John is here. He can probably specify that.
Yeah, feel free to type it in the chat.
I'll
The audio
I'll
does
try
not.
I'll try my audio. I'm outside and it's very windy, but
We can hear you.
okay, good. Yeah, I do teach an online Physics 1 course, calculus based, and I am always looking to modify labs and such, but I'm just interested in any kind of assessment that does look at their reasoning skills and such that isn't necessarily content based. So that I find that really interesting about the iStar. That is very thinking sort of based rather than content based. So I'm interested in using it in my online course, but I just don't know how much modification I might need to do in terms of say lab work and such. So I don't know if anybody's used it in an online environment before.
So during the pandemic, we had to move all of our labs online, like a lot of people. So because we were already so far into our lab curriculum, so for example, the pendulum lab, the students have to answer the researcher question, what affects the period of a pendulum? So they're going to take data, they get to decide how long the pendulum, change the mass, the angle, all that. So I literally went into the lab during COVID because we weren't allowed to be near other people and took videos of me releasing pendulum at different lengths and masses and angles, and each video is stored in a file with a name that says what are the variables for that. And so those videos are all freely available on our the workshops. I have a folder on OneDrive I can share with you if you're interested, and the videos are in that folder for people who want to keep using it online. We had great success, and we wrote an article for the physics teacher right after. It was such a good success. Could do the mathematical modeling. For me, the bigger concern with your question is using iStar online because students drop things into chat and GPT, and so I don't know how you get good controls Um, even though students do it in our class on Qualtrics, they use their laptops, but we're walking around making sure they're staying on the assessment because we don't want to. We know ChatGPT will give them an answer we're not interested in.
Yeah, that's always a problem is the looking up answers and stuff. So that's something we're struggling with exams, anyway. So perhaps we use something like Honor Lock or something for the
Right.
assessment tools. But okay. Yeah, I mean, I definitely would be interested in any lab modifications that you found useful for on the online environment. I'm always looking to change things up a bit.
Mhm.
I have a
So
quick question for I was just wondering whether you have what you do for E&M.
So you asked a great question. So all of our research up until this point has been primarily Physics 1 labs, and because that's what our grant funding was for. So we are just ending our last grant, and so we are moving into the Physics 2 labs. Our current Physics 2 labs use a lot of simulations. Um, there is some data collection, but it's really hard to ask students, what affects an electric field, because they don't even know what a field is. So they can't, it's not like a pendulum where they have some sense and they can make a prediction in variables. But I do have a grad student who is now ABD, and he is working on the Physics 2 lab curriculum. And we are collecting iSTAR data right now on our current Physics 2 lab curriculum. So we can see, is there any gains being made already in that curriculum, and then where we're going to make improvements. So we're working on it, but I don't have anything to share right now on that.
good question.
If you have ideas, you can share them with me. That'd be great. It's hard. It's just so hard.
Now, this is something I collected data on a long time ago about the Lawson test and the correlation with the FCI and the CSAM.
Mhm.
Curious, have you done something similar with the iStar instead of the Lawson test?
We did before COVID, and I don't remember not we did FCI in the iStar, and I don't remember the results being like over the top exciting, but we were still developing iStar at the time, and then COVID hit,
Yeah.
and we have not gone back to it, partly because we are over assessing our students right now. And even my students next week, they're going to be taking iStar and then a belonging survey and then the course eval, and we're just like you have to pick and choose. So I don't have a good answer, but I wish I could. I wish I had that data.
And the other thing that, in addition to the belonging questions, which there's only five of them, I believe, four or five, and we also have been using the E-class questions, but I've yet to wrap my head around how I'm going to use that, so I have some data. I got to figure out how to use it.
Okay.
Just because that's also a common tool used in lab, and we've been asked at national meetings if we use it. So we're trying to figure out, how to incorporate that into the analysis.
Okay. Has the iStar been adopted widely now, or are more people picking it up? Or what's your sense of that?
Yes, more people are picking it up. We're at the dissemination part of our latest grant, and so I have maybe 4 or 5 schools that are using it and then sending data. A lot of those schools, they're getting some shifts, not as large as the shifts as we have seen, but they're also trying to adapt their curriculum to infuse more of the scientific reasoning pieces. So they're not using our curriculum in full, because you have your local context you have to worry about and your local equipment. So they're seeing shifts, but not to the extent we've seen yet.
And likewise, at my 2-year college, we have shifts, but they're not as impressive as the larger data from main campus.
Mhm.
So whether it's the students, the implementation of it or whatever. So there's shifts though, and I'm, you know, that's what I focus on, not the fact that I have a small data set.
So here we're looking at the correlation between the iSTAR and the lab, especially the new version of the labs that you're putting together. But what about the other components of the course? Like, I want to let's use the word lecture for that, even if it may not be exactly a lecture format. But does that also have an impact on, do you think, on the outcome of the iSTAR to some extent? Does it reinforce it? Or is it kind of neutral as far as the students developing those skills in addition to what they're doing in the lab or in parallel?
I'm kind of
Most,
curious what Krista's answer is.
well, most of, our students who are in lab, they should be in lecture. We did have one slide through that was a train wreck. But so if they're taking lecture, the assessment tool is being administered in the lab section. Um, it the lab section is very focused on developing these particular scientific reasoning skills, where my lecture sections, which, like you said, aren't exactly lecture, are more on the problem solving. There's still critical thinking and some of the, skills are involved, but not as directly as they are compared to in lab, where we have activities that they work through that develop these skills. So it's just a better fit for us to use iStar in lab.
But
And
do you have separate lab and lecture sessions, or is it a blended format?
So ours are separate because my two-year college is part of the University of Cincinnati. So that's why they're separate. Um,
yeah, ours are separate because only about 80% of students need the lab. So they are entirely different courses. And when I teach lecture, and there's like, maybe 800 students and there's multiple faculty, I am the only faculty who knows what the students are doing in lab. That's how independent it is.
Mm.
So the lab curriculum does not always line up with the lecture. Like we start the semester with the pendulum so students can learn the skills, just control variables and things in a very hands-on, simple to understand context. And we do get to F equals MA about the time lecture does. And we do get to the rotation when lecture does, but they are independent. And I'm like, as Krista said in lecture, we're really focusing on problem solving skills, not experimental skills. So I don't think there's going to be much connection other than a student who is getting F equals MA in lecture may be able to digest the lab a little better because they already have some familiarity with the equation.
All right. Anybody else with questions?
Yes, I have a question. How would iStar work with maybe a lower level class like physical science or even an astronomy class?
So what I would do is give it to the students and see what it shows. And as I mentioned on that previous one of the slides, we have a pool of questions, and we have pulled out of that pool the questions that we've already created, but we're only looking at 22 of them now. So you might find in that pool some questions that might be at a level that your students might be, or those students would be more accessible to, if that makes sense. So some of the causal decision-making questions on the pre-test, we might have a 0.2, 20% get it correct, and then it only shifts to 25%. That question may not be useful in your context. And so you could just replace it with a question from that pool that might give you a better discrimination factor with your students. But you have to do some exploration. And I will say we have not used it with our physical science. We have that course on campus or our astronomy classes. So I don't know the answer to that.
Okay. Okay. Any other question for our speakers? Uh,
I have a
oh,
question for the participants. I'm curious how many are thinking about testing their students' scientific reasoning using iStar.
I am. I am because I'm actually wanting to follow up on what I did with the Lawson test, and so and also use it as a good reason for doing something that I've been meaning to do for a long time, which is change our labs, or I don't want to say change, but improve our labs by adding pieces to them that would really help in that. Before I fully retire. So that's going to be my mission for the next for the next 3 years.
So if you still have students left this semester and you wanted to assess them real quick, and you only have a post-test measure, of course,
Mhm.
but if you want to do that, reach out to me. I can give you a link real quick with Qualtrics. You can get data fast. It's up to you.
Well, we have one session Monday, and then they have a test on Wednesday, and
Got
then
it. Yeah. It's hard to fit in.
yeah. But yeah, definitely for the fall, I'm actually going to talk to my colleagues about this because we've been doing so many of those things that I think it would be a nice fit for what we're trying to do on campus because we've been doing the sense of belonging, we've done the CLAS, we've done the FCI and the CSAM, and now we've done the BEMA. So I think uh, because we have these learning outcomes for the college, so for all the science courses, the stated learning outcome is scientific reasoning. And I've always complained that what we're doing is not really assessing scientific reasoning. I never felt that the tools that we are putting together, because my reasoning is, look, it takes years and a lot of expertise to really produce questions that are truly assessing something like this. And here we are putting together a few questions, and we think we're able to assess that. And I always complain about it. Nobody listens to me, but I'm going to try to come
But
back with a stronger argument now.
Kathy and her team have been, working on this 20 years. So
Yes.
it's not something that was just thrown together and we're just now talking about it. We
Yeah,
we
I'm
didn't want to
aware of
talk
it.
about it until we feel we're more comfortable.
Yeah, I want to. Sometimes I want to strangle my colleagues when they think they can just put some questions together and call that an assessment. And I say, "Ah, if you knew what goes into some, I mean, I've never done it per se, but I've heard enough people telling us how to do it that I know it's not it's a challenge.
So, in terms of thinking about using iSTAR, I could be leaning towards using it, but the local context is really something that you always have to navigate. And so I'm just trying to understand how, especially for Physics One, which a curriculum like what you do at UC and at Priestess College, Blue Ash, is really something I resonate with, and I think my students would really benefit from because we have a series of labs, sometimes not very connected, and but you have to navigate the fact that there is a lab that's set up this way, and you come in and try to set things a little differently sometimes, and so that makes it a little hard to kind of navigate how you're gonna try to have students do something for like 4 weeks in a row, you know. So that's my challenge, but I would like to try the
Well, I
iStar.
think it would be informative to give them iStar pre and post with what you're currently using. Because
Mm-hmm.
if it's already developing their skills, maybe you're set. And then if it isn't developing your skills, it gives you information as to what you can tweak, whether it's with your own current lab curriculum or, um, if you want to incorporate some part of the SR labs, they're
Mm-hmm.
available to just take bits of it, some parts, like designing your own experiment. Kathy's got a great template that helps
Mm-hmm.
students think through that. But whatever it is, whatever part of that might help you get the students where you need to be. You don't have to
Yeah.
adopt everything. You can you can try little bits and see if that moves the needle and whatever's manageable and whatever works for your setting.
Mm-hmm. Mm-hmm. Yeah, exactly.
Well, I definitely appreciate all of you for taking time out of your Friday. And
Well,
we are going to be around if you have other questions. And I encourage you to see the 2024 SR Lab workshop that's posted on the optics site under continuing professional development. That'll give you a sense of, is there parts of that lab you'd like to try? And then also connect with, you can connect with me, but as I'm retired recently, your safer bet would be to directly contact Kathy. She's very good at
What?
answering emails. I'm working on it, but I'm a little slower these days. That grandbaby is starting to take more of my attention.
Yep. Just let me know how I can help you or any questions you have.
So I want to also remind everybody that we have a link in the chat for a short survey of our session. And I want to thank also Krista and Kathy for coming to tell us all about this. I think it was very informative and very helpful, give us a lot of ideas. And I think with this, I guess, Chris, we can probably conclude the recording. And of course, as you said, we can stick around for additional questions if anybody wants to.